Hello people, welcome to this video, and in this video we are going to cover how to do exploratory data analysis using Python. Okay, so the table of contents are as follows. So first we will see like why ED is necessary, and then we will understand the basic functions of pandas like head, tail, etc. Okay, then we will deal with missing data in the data set. We'll deal with outlier detection using IQR like and box plot and z-score. Okay, then we will do some visual analysis using matplotlib or seaborn as required. Lastly, we will have some intro about why feature engineering is necessary with respect to data analysis, and lastly we will revise like whatever things we have learned. Okay, so coming to the first point, that is importance of EDA. So whatever things you do in data analysis, EDA is extremely crucial part. Okay, so basically everyone needs to know like exploratory data analysis, like why it is needed, what it has like uses. Okay, so there are few steps involved in EDA. Okay, so what we do is in the first step we collect the data. So we can collect the data from different resources, and data may be like it may have different domains of data. For example, it may be customer data for like whatever the data they use in terms of customer support, like for example Flipkart, then Amazon, right? Then we may have sales data. So data may be specific to different domains. Okay, so after loading the data, what we do is we try to distinguish the attributes. Attributes in the sense features. For example, like age, then gender, then like if the person may have income. So these attributes we try to distinguish. Okay, then we do univariate analysis, then bivariate analysis, multivariate analysis. Okay, so univariate in the sense like we consider only a single attribute. For example, consider just the age. Okay, that is univariate analysis, like how it is like correlated to or associated to whatever we are trying to analyze. Okay, so that we do in univariate analysis. So in bivariate, as the name suggests, we consider two features. Okay, and multivariate we consider many features with respect to each other. Okay, so then what we do is we detect the like missing values, right? Then then we deal with them, then we detect the outliers. Okay, then lastly comes the feature engineering. Okay, and after feature engineering, what we'll do is we select the required specific features for model building, and then we will test the model, validate the model, and then we launch the model, okay, to the cloud for its proper working. So that's how like the process goes. So first we load the data, then like we find the analysis of attributes like which are necessary, we deal with the outliers, okay, missing values, then we do feature engineering, feature selection, then lastly model building and model deployment. Okay, so these are the steps involved in overall process of data analysis. So it is needed to to see which features are important. For example, if you consider the sales data, so suppose if like if you're targeting particular area, and that area may be metro city. Okay, so those areas may have a high sale order. Okay, so that's how we can understand from the data. And if there is an rural area which may not get many orders, okay, so we try to either increase the sales in rural areas by giving them some offers, or we try to retarget the metro city areas to increase more number of sales like from the existing ones. Okay, so this is how we do using the EDA concepts. Okay, like we analyze what features are important to in order to grow our business. Okay, that's the whole idea about EDA. Then in case of machine learning, why EDA is important? So we are preparing the data for our machine learning algorithms, for example regression, classification, okay, then decision tree, random forest, etc. So whatever algorithms you are using, those algorithms need the data, like exact data, or the data which is only important or useful for your analysis. Okay, so that data you need to feed to your algorithm. Okay, and then you need to build and train your model, and lastly the model deployment happens. Okay, so in machine learning algorithm, whatever data that you feed, which is the core need, that we identify using EDA. Okay, so in today's EDA concept, to understand EDA, we are using the same data which we had used earlier in our previous lecture, that is Python for data analysis. So you can check that video also. So we are using the same data. Okay, so let's understand the data first, and before that let's import the libraries. Okay, so shift enter. Okay, now let's load the data basically. So it might take some time. So yeah, that's it. So with respect to this data, let's understand the data first. Okay, so there are different features here. Okay, and here you can see the type is given, a numeric, integer, or categorical. Okay, so just you need to have there are two types of data in case of data set. Either it is a categorical or it is integer. Okay, so ADR is nothing but average daily rate. Okay, like how many customers are like the rate of customers visiting the hotel on average basis on daily. Okay, so there are some features here like BO, BL, and TR. Okay, so that is this, where it is, yeah, this one. So it is bookings change log. Okay, and TR is transactions, and BO is bookings, ML is meals, and the distribution channels is DC. Okay, market segments, then nationalities, customer profiles. Okay, so these are some short forms you need to understand. Okay, so just we will have a look into like important features. So ADR is an important feature here. Then adults, then agent is nothing but he is act like a travel agency that made your booking, like a mid broker. Okay, then arrival date of the month. So as the name suggests, directly you can understand from this. Then okay, arrival date, day of month, then arrival date of month, then week, number, then date, year. Okay, then assigned room type. Okay, so the room may be of different types. Then number of babies here, then children, company, country. Okay, then customer type. Okay, so whether it is a regular or he is a new, or he has visited in a group. Okay, like that. Okay, then day in waiting list. Okay, so deposit type, like how they have deposited the amount. Okay, so is cancelled, this is the important feature. Okay, so this is you can consider this as a target variable. That means you are trying to analyze this variable with respect to other variables or features. So whenever I say variables or features or attributes, all mean that they are different columns. Okay, so target variables means how like other variables are associated with this. So is cancelled in the sense, so cancelled, they have cancelled the booking in the sense 1 is given, and if they are not cancelled it is 0. Okay, that means if 0 it is booked. Okay, that is the thing. So if the gets are repeated or not. So lead time is like number of days elapsed between the entering date of booking into the PMS. So PMS is nothing but their system in which they have all the details of their customers. Okay, and then a segment, then meal type is also different. Here you can see bed and breakfast, half board, that means only breakfast and one other meal, usually dinner. Okay, then full board, like that. Okay, then there are some other features also, you can look that out. Okay, so without wasting further ado, like let's move ahead. Okay, so with respect to understanding basics of pandas, so here is the important feature, that is data.head. So data.head gives us first 5 values. Okay, so 0, 1, 2, 3, 4, and 5. Okay, so here you can see like there are around many columns, or you can say features. Okay, and here if you specify the number, you will get those many features. Okay, so here you can see up till 19. Okay, so we don't want to specify those, so let's specify only data.head. So data.tail gives us the last 5 values. Okay, so here you can see like we have around more than 1 lakh plus rows or data. Okay, and sample is like you are selecting random values from the whole data set. So every time I run this, you will get some different values. Okay, and data.shape will give us like total number of rows, that these many, and total number of columns here. Okay, so okay, that's it. And then we looked into the information about the data. Okay, and data.info will give us information about the columns. Okay, basically, so here you can see hotel. So we will look into it. So how many non-null values are there? That means some values can be empty here. Here you can see 86, that means 90. 4 values are missing here, I think. Yeah, so and also you can see the data type, that is object, int 64, and then float 64. Okay, so object means string data type you can consider. Okay, then okay, there is one more feature in pandas, that is value counts. So basically what it does is it works on categorical values. Okay, so it gives us like subcategories in present in categorical value. For example, in case of hotel, there are categorical values of city hotel or resort hotel. Okay, so and the count of those values in that column. Okay, so that is how value counts is given. Then in case of meals also, you can see that it is uh, half board, full board. Okay, then breakfast, like that. Okay, so these many undefined is it is not defined, or maybe they are not interested, like that. Okay, so this is how the value counts you can do. Okay, and then we can also see the other columns also, like reservation status, like whether they have checked out, cancelled, or like that. Okay, and the other feature is data.describe. So include all in the sense it will give us all the categorical values also. Here you can see wherever there is nan present, it says it is about a string or categorical value. Okay, so we don't want that, so let's go with describe. So it gives only the numerical columns. Okay, so in case of describe, we get like count of values. Okay, how many are present, then mean, SDD, that is standard deviation, then min, and then 25%, this is Q1, then Q2 is median, and Q3 is 75% of data, and max value. Okay, so this is what we get in case of describe of each column. Okay, so you need to understand this, so and look into it, like how it is distributed. So in terms of like pandas, there are also many other features also. Okay, so like we will explore it. Okay, so one by one we will try to explore it. Also, like if you have some other techniques of pandas, you can just comment them out. Okay, so that everybody can like coordinate with it and learn. Okay, and the next is like handling missing data. Okay, so once we look into the data, we will see like how many values are missing. So this is the function you can use to calculate the missing value. So data dot is null dot sum. So is null is nothing but how many null values are there, and total sum in that particular column it will give. So hotel has 0 missing values. Okay, so this is how it gives. So here you can see we saw that children had 4 missing values, then country had like 488. Okay, then company has around like 1 lakh values missing. Okay, so we don't need this column company, so we can drop that. Okay, so agent also has some missing values. Okay, so we will deal with these missing values first. Okay, so first of all, we are dropping the company column itself because it has like 1 lakh plus values missing. So we have dropped it. So data.drop the name of column, then axis 1 is this axis. Okay, and then in place true, that means it is like doing it in the data set itself. Okay, so it is directly dealing it like deleting it from the data. Okay, as long as we are doing the calculations. So whenever you move ahead from this, you won't have this column, but if you run it again till here, it will have the column. Okay, so that's how it works. Okay, then we dropped this column. Okay, so if I try to run this again, you will see that error. So it is running again, you can see that it is facing some issue now. So yeah, here you can see that it says like no, not found in axis. That means we have already deleted it, right? So that is why it will throw the error. Okay, so let's comment it out. Now to replace the missing values, what we do is we will have 3 things. For numerical, we deal with either mean or median. Okay, so we can replace these values with either mean or median as needed. Okay, and so mean is always affected by outliers. Okay, so what are outliers basically? So those data points which can hinder your analysis. For example, suppose there is you are calculating the average weight of the class. Okay, so everyone's age lies between age group of 10 to from 40 to 60, let's say 40 to 60. Okay, and then there are 2-3 people whose age is around 80 and 90. So this will directly affect the average weight. Okay, so that is how like mean sometimes affects, sometimes it will not. Okay, so it depends totally on the calculation how you are dealing with it. Okay, so we will calculate the median of children first. Okay, so median is like 0. Okay, and then like mean is, you can see 0.10. Okay, so there is no much difference, you can use anything. Sometimes the mean and median are like differs widely. Okay, so at that time you need to think over like what you need to use. So in this case you can use anything. So I'm going with like mean here. Okay, sorry, median. Okay, in case of children, here you can see. Okay, Now for agent also we are calculating the median. So where is agent? Yeah, this one, agent. Okay, so if now if you calculate okay, let's say median sorry, mean for agent. Let's calculate mean for agent. Okay, so let's see how much it varies. So here you can see, now you will understand this. So here the mean of agent is 86.69 and median is 14. So median is nothing but it takes the exact middle value. So it will not be affected by the outliers whether they are present extreme end or at the starting position. Okay, so that's why in many cases we consider median. Okay, but in the end it totally depends on the analysis or the analyzing agent who is doing the job. Okay, so for agent also we are taking median. So and for children also we are taking the median. Okay, now I have replaced the null values with median of agent, and also the children I have replaced the values. Now if I run the is null sum, here you can see that the agent and children is 0 0. That means left is country. Okay, so country is basically categorical column. Okay, so here you can see the data type is O means object. Okay, now to do the replace the missing values of object data type, what we do is we consider the mode in this sense, which is repeating frequently, like which category in that column is frequent or more. Okay, so that is mode. So mode of country is PRT. Okay, so that country column we are replacing with mode 1. Okay, basically this. Now the difference between this, here we have not used in place is equal to true. That is why we are directly assigning this to data.country. But in case of this, we are giving in place is equal to true. That is and that is why we are not using like this. Okay, so this is the difference between this assignment. Okay, now this we have done. Now let's check this sum. Now the data is clean, or we have dealt with the missing values. Okay, that's it. Okay, so this is how you deal with the missing values. So now the data, there is no missing point in the data set. Okay, now here you can see that there are a few rows. Okay, that is 180 rows where the sum of adults and babies and children is equal to 0. Okay, so what that means is in adult column and babies column and in children column everything is 0. Okay, so these data points are no important, right? It is not important, this data point, so we will drop those. So how to drop those? So what we do is data of adult, so we will place the same query here which is equal to 0, and in index we will drop that. So data dot drop this query, and then in place is equal to true. So this will deal with the drop data. Okay, so now if I check the shape, here you can see there are no values. Okay, so this is how we can deal with some other values or data cleaning, you can say. This is done in this way. Now next is we need to find out how many duplicate values are there. So here you can see 32,000 duplicate values are there. So this function duplicate is equal to data dot duplicated. So this function will give us duplicate values present in this data. Okay, and we are storing it in duplicate. Okay, now what we are doing is duplicate dot sum we are printing, so we are getting these values. Now data dot drop duplicates and in place is equal to true. That's it, it will do the job. Okay, and if I check it again, you see there are no duplicates values. Okay, so let's check the final shape of data. So here we have dropped the one column. Okay, and the remaining data is 87,000 rows. Okay, so there were around 1 lakh plus rows. Now we came to 87,000. Okay, so this is how usually done with respect to the data. We are cleaning the data, we are dealing with missing values. Okay, so in terms of real data sets, it will be million plus of rows. Okay, so that we need to do, it takes time, lot of time. Okay, so we are just dealing with it in brief. Okay, so whatever things are needed, we are dealing with that. Okay, now if you want to separate numerical variables and what you say categorical variables, okay, so we can direct you can use this function. So data dot select data types exclude object, so this selects only numerical features. Okay, and exclude category, if like exclude numerical, it will select the categorical features. Okay, so now we are trying to find out the correlation. Okay, how each data is related with each other, or you can say associated with each other. For example, if you consider the age and weight column, if as the person's age increases, its weight also increases. Okay, so this is how some columns may be related with each other. So that feature is given by correlation. Okay, so in terms of numerical aspect, you can find out this in this way. That means, so here you can see that is cancelled and is cancelled feature is directly here, the correlation is 1. That means, like, obviously both the values are same, that is why it is giving as 1. Okay, and some correlative features are like in negative. Okay, that means there is no relation. That means if one is increasing, the other decreasing, like that. Okay, so then lead time and is cancelled, there is 0.1% of correlation, like that. So arrival date and is cancelled, like it's 0.08, like it's minimum. Okay, so some things may go in negative. So these things, like sometimes it may be difficult to analyze it using this visualization, but if you use heat map, okay, so it is very easy. Okay, so let's generate this heat map. So we are using cmon library sns.heatmap. We are giving this correlation, that means this data we are giving it here, and after, in the sense, it will show us the figures, and then 0.2f in the sense 2 decimal places, and the size of the values inside we are giving as 7. Okay, and square is equal to true. So if I give this as 8, you can see that the size of numbers increases, this one. Okay, so it may not be much difference. So if I give 10 here, you can see that it will cross the square. Okay, so now it is much bigger, right? So let's go with 7 itself, so that every data is visible. Now this bar is given here, which shows how it is correlated. That means lighter the color, the more features are correlated. So you can directly go here. Here you can see stays in weeknights is like highly correlated with, which feature is this? Yeah, down, I think it's so the stays in weeknights is highly correlated with weekend nights. Okay, so similarly there is not much correlation with other features. Okay, so the light colors are only few. Here you can see like previous booking not cancelled is somewhat correlated to is repeated guest. Okay, so the repeated guests have cancelled the bookings, like not cancelled the bookings, like that. Okay, so this is how you find the correlation. Okay, now there are ways to detect. The next thing is outlier detection. Okay, so there are ways to detect the outliers basically. So one is IQR method, and the other is box plot, and other is the z score. Okay, so in terms of box plot, here you can see the column stays in weeknights. Okay, so if I run this, you will see that there are some outliers. So the data which is good for you is basically lies in this range. So this first line is called like minimum. This is 25%, this is 50, and this is 75, and this is max. Okay, so the middle line of box plot is nothing but the median. Okay, so your the data which is good for analysis or machine learning is basically this, but it totally depends on the type of data you're dealing with. Okay, sometimes this data may be good for analysis, sometimes it may be bad. Okay, so this is how you can detect the outliers using box plot. Like directly draw the box plot of whichever feature is needed, and you can like understand how the data is, like whether it has outliers or not. Okay, and now okay, we can see the lead time also. Here there are so much outliers. Okay, now using IQR. Now what is IQR burst? So IQR is nothing but interquartile range. Okay, so interquartile range is nothing but like how this data is related, like that is Q3 minus Q1, basically interquartile range. So difference between 75% of data minus 25% of data will give you IQR. Okay, so outliers are nothing but the points which are above this. So quarter 3 plus 1.5 times IQR. So whatever value comes this above this point is an outlier, and quarter 1 minus 1.5 times IQR below this point is an outlier. Okay, so this is how outliers are determined. Okay, which are not valid or which can hinder your analysis. Those data points are calculated in this way. So to remove the outliers, what we can do is, so we are considering which column here, lead time. Okay, so here you can see now there are so many outliers. Okay, so to remove those, what we are doing is we are calculating first quarter 1 and quarter 2, and there is a inbuilt function that is column dot quartiles 0.25 0.75. So 0.25 will be stored in q1 quarter 3, 0.75 will be stored in quarter 3. Okay, so IQR is calculated IQ3 minus q1. Okay, so lower range is given this, basically this, and upper range is given this is this. Okay, and we are returning the lower range and upper range. Okay, so whatever data points below this and above this will be dropped directly. So we are passing this function in this. Okay, so we are firstly, since this function returns two values, that is lower range and upper range, what we are doing is we are taking low lead time and up lead time. Okay, so because it is a lead time, now remove outlier in the sense data dot lead time. Okay, so we are passing the data column to this function remove outlier. Now this column will go here. Okay, so first it will sort the column, that means from 0 to 100, in ascending order, small to big. Okay, and after that what it does is it will give us lower range and upper range. Now in terms of lead time, what we are doing indirectly in the column itself, we are checking the values using NumPy library. Now np where the data column, if it is greater than up lead time. Okay, so this up lead time we are replacing with up lead time in the sense the maximum range. So this value we are replacing with it, the maximum range. Okay, and we are adding it in this. Similarly for low lead time, so which is lesser than low lead time, we are replacing it with it low lead time. Okay, in the data set. Now if I run this, okay, remote light is not defined, so let's run this. Now it is run. Okay, so now if I plot the box plot of lead time, you can see there are no outliers. So basically it trims the data above 280, I think. Okay, so let's check here. Yeah, here you can see it is nearly till 300 the data is cleaned. After that the data is outliers are present, so it has cleaned the data. So this is how you can use IQR to remove the outliers from a particular column. So if you want to remove the outliers from all the columns, what you can do is just use the data dot columns and use a for loop. You can try this out. Okay, so next is the z-score method to deal with the outliers. So what is z-score? So it is a standardized score, basically, that is numerical measure. So it gives us it says numerical measure of how far an individual score is away from mean score. That means here you can see this is the formula of z-score. That is, x is nothing but the data point minus nu is the mean, and sd is the standard deviation. And whenever you see the data structure or the data points, the flow, the data is distributed in this manner. That means this is 1 sd. Okay, so from mean till this point, 34% of data is considered as one standard deviation. Okay, and then till 2 standard deviation, around 97% of data is there. Okay, so 30 30 60 68 78 88 plus 6, so 93. Okay, so around 94% of data is there here. Okay, and the remaining is this, so around 90 94 95, around 95, and remaining this. Okay, or 97 you can see. So this is how the distribution is done. Okay, so what we do is, so we subtract mean from original data point and we divide it by sd. Okay, so if it is greater than, now if the z value is greater than 3 or less than -3, what we do is we consider it as an outlier. Okay, because here you can see up to 3 standard deviation every data in the data set is covered. Okay, so that is why the threshold is considered as 3 here. Okay, so this we will see, but since we are cleaning the stays in weeks, this data set we are cleaning, this data feature we are cleaning. Okay, so before that I just want to run this scatter plot, so that since we are cleaning it. Okay, that's the thing. Oh, sorry, this is not new. Okay, so yeah, So now we can run this. So now what happens here, stays in weeknight. So we are using okay, where it went. Okay, so we are using this for loop we are using. So for I in data of stays in weeknights, that means every data point it goes, it will first find the ST, that is standard deviation, and then mean, and the threshold we are giving as 3. Okay, so data point minus mean upon ST, that is the formula. Okay, that is Z. Now if Z is greater than or equal to B, that means threshold we are checking. Okay, so we are directly dropping the data point which is equal to I. Okay, that means because it is greater than B, right? So that is we are dropping it, and in place we are giving it as true, since it will drop in the original data set itself. So if I run this, so whether it is running, yeah, it's running. So let it run. It may take some time. Okay, because sometimes it may take time since the data set is big enough. Okay, so it has to iterate over around 87,000 rows, and then it needs to do those many functions, right? So that is why it takes some time. Okay, so yeah, so let's wait for a while till it runs. Okay, so if you have any doubt in the above sections, you can just comment it out. Okay, or if you have some other better ideas or shortcuts or to deal with the data or to do exploratory data analysis, you can just comment it out in the comment section. Okay, so that we can keep the engagement real, and so that everybody can learn it in a good way. Okay, so like try to practice it using the Jupyter notebook or along with me now. Okay, if you have the dataset, you can also download the dataset from the Kaggle. Okay, where you will have the same data. Okay, and while running like while I am doing, you can also do it with me. Okay, so that it will be helpful for you. Now the data is clean, it has stopped. Now let's check like how the data is. Sorry, so control this. Okay, now here you can see it has deleted all the values above 6. Okay, so here you can see like around 6 7 it is, after 6 7 it is having outliers, right? So it is dealing with that, right? So this is how you can deal with the outliers using z-score. Okay, so 3 things you can use for outlier detection, that is IQR, z-score, and box plot. Okay, there may be some other methods also, do explore them out. Okay, now next is like visual analysis. So for pair plot it may take some time. Okay, so let's run it at the end. Okay, so first we'll understand this data like histogram. Okay, so let's understand this data first. Till that I will keep the other things running. Okay, so let's run this. Okay, so let's understand these points first, and I will keep this running. Okay, so now the pair plot is running, because since there are many columns, pair plot like it requires some time here. Okay, so I wanted to run it beforehand, but still okay, no, not an issue. Okay, so what does the hist plot deals with? So hist plot deals with single column. Okay, so basically it may be numerical column. Okay, so it should be numerical column. So because bar plot deals with categorical values. Okay, so we are finding the average daily rate, that is how many people are coming or booking the hotel on the daily basis, and bins 20 in the sense the divisions that it makes. Okay, so if I give the 30 here, okay, it may not run because our kernel is running here. Okay, so the more number of divisions is specified by the bins here. Okay, so once it runs, I will show you that. Okay, and the figure size is given using this plt.figure fig size 12. So 12 is nothing but the x-axis, and 6 is nothing but the y-axis height. Okay, and here you can see this is the ADR, and the count, that is the number of people that are booking, is given in the y. Okay, so this is how histogram is plotted. Now next is we are using count plot here basically. Okay, so yeah, so sns.count plot, it takes 3 things. Okay, sorry, 2 things. So one, we are giving hotel. Okay, and then hue is nothing but this one, hue is nothing but the color. Okay, so is cancelled column, it has 2 things, right? 0 and 1. Okay, so 1 is cancelled and 0 is booked. Okay, so Here the resort hotel has low number of cancellations, you can say, because like we are thinking it has low number of cancellations since the graph is small, but the analysis may go wrong. Okay, so you need to have the actual number so that you can get it. So here you can see like a number of cancellations are like 23,000 total. Okay, considering resort hotel and city hotel. Okay, and the bookings are 61,000. So what you need to do is in hotel data set, like why these people are canceling the hotels bookings, what are the issues. Okay, so in case you are running a real-time hotel, so why these people are canceling the bookings. Okay, so that are the things you need to find out using this data. Okay, so that is how we do the analysis. Now we are finding reservation status in different hotels. So yeah, so to go with the plot, the title is this, so whatever we are giving it, and X label is this, it is hotel, and number of reservations is Y label, and plt.show is to show you the plot. Okay, and this we have dealt with. Now bar plot is, here you can see we are giving is cancelled. Okay, so not cancelled is labeled as this, so around 61,000 people have not cancelled, and cancelled is this. So you can also give like bar a label, not cancelled, and cancelled is given, so data is cancelled dot value count. So basically we are passing value counts as the chart, and the width is given as 0.8. okay, so width you can increase or decrease. Okay, so now you can see the yeah, so this is about the bar part. Okay, the kernel has stopped running, so our SNS plot may have been ready. Okay, so since it took time, it had to plot so many different graphs. Okay, so basically it plots around like more number of like numerical features it basically plots. Okay, so here you can see if I zoom in, it is cancelled, then lead time, then arrival date. Okay, so it plots the graph with respect to each other in case of x and y axis. Okay, so here you can see the distribution of data point. So here the data is like distributed everywhere. Here data is like skewed, it is present right and left side. So this is how assumptions are made. So this data, like it is associated, since it is like somewhat associated. Here you can see like most of the data points are like here. Okay, so like this means they are correlated. Okay, so to show you the exact correlation, there is no data point available here proper. Okay, so this is like everywhere the data is scattered here. Okay, so this is how the pair plot gives, like it is gives the visual representation of every column with respect to the other column. Okay, like a heat map you can see. Okay, so this is how the pair plot is. Now we dealt with this. Next is so basically we are dealing with again the box plot. Okay, so what does box plot do here is so we dropped the ADR value which is greater than 5,000 because it was an outlier and it was hindering our analysis. So you can pause that time there. So you might have seen that these graphs were a bit down because of the value 5,000. So I dropped that. Now what I'm doing is I'm specifying the columns as Jan, Feb, March, April on the x-axis, and then I'm giving data dot arrival date month. Okay, and pd dot categorical. Okay, so data of this column I'm giving, and then I'm passing re-index, that means this I'm passing here. Okay, and I'm giving ordered as true. Okay, and then specifying figure size as this, and then I'm plotting it the box plot. Okay, so once you plot this, you will see that arrival date of month, and then ADR, how like average daily rate of customers, how much they are. Okay, so in August you can see like there are more number of people arriving at the hotel or bookings are done, you can see. Okay, so least might be somewhere here. So yeah, so least might be Jan, or you can say December, or these three things are considered. Okay, so but the peak season is between April and Oct. Okay, so this is how you can draw the analysis. Okay, now there are some outliers present here, you can see. So with respect to this data set, like these outliers may be needed. Okay, so yeah, next is scatter plot. Like we are finding the association between two numerical columns. that is ADR and stays in weeknights. Okay, so how people are staying. Okay, and then here you can see these many number of nights people are staying, and these are the number of people. So around 100 people are staying in this range. Okay, so here you can see like around, like there are people, but maximum people are like 10 days. Okay, then 200 people. Okay, here there is 150, for 50 days people had booked some hotels, so like that. Okay, so this is how the scatter plot is done. Okay, then there is one more plot, that is count plot we are doing. So this will help us to analyze like how long the booking was made. For example, how many bookings were made. Okay, with respect to the stay. Okay, so in case of resort hotel and city hotel, like how many are there. So in case of resort hotel, you can see cancelled and sorry, not cancelled, resort hotel and city hotel. Okay, so these many number of bookings were done and for this many nights. Okay, so 2000 people booked for around like 0. So I think these are cancelled seats. Okay, not cancelled. Okay, 0 in the sense I think cancelled. Okay, so for one night of stay, these many people booked. In case of resort, for 2 days, 3 days, 4 days, like that it is plotting. Okay, so how we have plotted that count plot, we have given stays in weeknights for x-axis, and then data, and then view for hotel. Okay, so palette crest in the sense the color of graph whatever they are seeing. Okay, and then in case of x label, so label in the sense whatever we are giving this length of stay, and y label is number of bookings here, and plt dot show is for graph. Okay, so this is how the analysis is done. Okay, so the next concept is about feature engineering. Okay, so feature engineering is done basically for many things. Okay, so feature engineering is done to analyze which features are necessary in order to grow your business. Okay, so like you need to have some domain knowledge. Like if you are working for e-commerce and you have the domain knowledge of e-commerce, you may understand like which feature is needed and which feature is necessary, which features are not necessary. Okay, so that is done in feature engineering. Next is you can draw some features from the existing features. Okay, so that we can do. Okay, so or you can, what we can do, we can combine two features into one feature. Okay, so that we can do. So those things comes in feature engineering. Okay, so and also it consists of like standardization, normalization, then it has one hot encoding. Okay, so feature engineering, like it is the most important part to give your model the features that are necessary. Okay, so if you have many features and which are irrelevant to the data or analysis, it may hinder the analysis. Okay, so that is why feature engineering is needed. Okay, so in glimpse, here you can see the raw data. Okay, first we will do the feature engineering. That means like after EDA we do feature engineering, or you can consider that EDA is a part of also feature engineering. Okay, but in depth we do the feature engineering, like we study each feature in depth, whether it is necessary or not, how it might affect our target variable in order to grow our business, like that. Okay, so then we draw the important features and we give to model. Okay, and then model is built and it is deployed. Okay, so what is feature engineering in small, like in short, we can say that it is the process of transforming raw data into features that are suitable for machine learning models or real-time analysis. Here you can say that. Okay, so that is why feature engineering is needed. Okay, so I think this section we are going to do it in the next part of the video. Okay, so for this video this is sufficient enough to understand like how EDA is done using Python. Okay, so basically we started with like loading the data, understanding why EDA is important. Okay, then we did some pandas operations, we understood the data. Okay, so we dealt with missing values, outliers, then we did some visualizations. Okay, so these are the things like basically followed, or the common steps followed in EDA. Okay, so some steps may it depends on the analyzer. Okay, so you may do outliers first and then visualization. Some people may do visualization first and then outliers. Okay, so everything is goes the side by side. Okay, so and it also differs with respect to the data what you are having. Okay, so here you can see I did the scatter plot first, right? I ran this tab first to show you this scatter plot, then I removed the outliers. Okay, so if here you can see there are outliers. Okay, so in this case I visualized the data first and then remove the outliers. Okay, but in case of model selection, like for model, you need to remove the outliers then feed the data. Okay, so this is how it goes. Okay, so you need to understand the data, and working on data set is a huge task, and cleaning the data requires like around 60% of the time. Okay, so that is how it goes. Okay, in real time. So data is very crucial. Okay, so and to draw the meaningful data is very important. Okay, if you draw irrelevant data, then it may like go in the reverse order, it may hamper your business. Okay, so to do the analysis, the first step is ED. First and foremost step is ED. So do understand this concept very thoroughly, have a good hands-on in this. Okay, and yeah, so if you learned and understood something from this video, it is good. Okay, if you do not just comment it out, whatever section you did not understand. Okay, and also you can give some information about your techniques that you used in the EDA. Okay, so that it can help out the people. Okay, and yeah, that's about it. And if you have come till this end, do explore our site, that is Project Pro. Okay, so basically it has like many projects related to machine learning, then data science. Okay, we have also mentor sessions, like one-on-one sessions to the people, okay, who have difficulties in understanding. Okay, and then like we can also give you the resources here, you can also check that out. Okay, and also there are many projects here available based on different like NN, DL, NLP. Okay, TensorFlow, machine learning, DL. Okay, so check those out, check out our site, and yeah, hope you find this interesting. Okay, also do subscribe our YouTube channel, and if you learned something from this video. Okay, so if you do, so do subscribe, share, and like this video. And if you have some doubts, you can comment it out, people, like I will solve those comments. Okay, so if you learned something from this video, do hit the subscribe button, and till then, take care, bye bye.